Hello, people from the future. Welcome to Normalized Nerd. Today, I am very excited to talk about how you can simulate 2D elastic collision in your computer. Well, I will be using P5JS, which is a JavaScript based library to simulate to write the code of this 2D elastic collision simulator. And before starting the video, I want to talk about why I want to make this video. Well, when a few years ago, when I was in my school, when I was dealing with all kinds of physics problems, I always wanted to visualize the problems, but I didn't have any tool to do that. So now I know coding and I can code these things, the collisions and all kind of physics stuffs. So I want to show you how you can simulate them too. Okay, so let's get started. So here you can see on your screen is the web app, the final web app. This is the 2D collision, elastic collision simulator, and you can see that there is a screen where two balls are there. One is red, another is blue, and you can see that some lines are poking out of the ball. Well, these lines basically represents the speed of the ball. Well, if I increase the speed, here you can see the length of the line is changing. Same for this ball also, and we can adjust the angles also, like this one, like this one, and we can also adjust the positions, the starting positions. Suppose let me give it this initial position and let me just press the run button, and you can see it just simulates the actual 2D collision, and it actually follows the laws of physics, the conservation of kinetic energy and conservation of linear momentum. So as usual, we are gonna first look into the concept, and after that I'm gonna show you the code. So for simplicity, let us first analyze the 1D collision case. This is the 1D collision, and we are having two balls approaching towards each other with the velocities u1 and u2, and the masses of these balls are m1 and m2. And after the elastic collision, suppose the two balls reaches the velocities of v1 and v2. Okay, the masses are obviously going to be the same one, and remember that whenever we are dealing with a elastic collision case, the linear momentum must conserve and the kinetic energy must conserve. So we are going to have two equations. The first equation is the conservation of momentum conservation, and this says that m1 times v1 is the velocity after the collision, plus m2 times v2 must be equal to m1 times u1 plus m2 times u2. And if we just consider the kinetic energy conservation, we are going to have the following equation: half m1 v1 square plus half m2 v2 square must be equal to, oops, half m1 u1 square plus half m2 u2 square. And if we solve the two equations, which I am definitely not going to solve here because it takes a little bit of time, I'm just going to write the value of v1 after solving the equation. We will definitely get v1 equal to m1 minus m2 divided by m1 plus m2 times u1 plus 2m2 divided by m1 plus m2 and multiplied with u2. So this represents the velocity of the first ball after the collision, and similarly we can solve for v2 also, and you will get another formula for v2, and in that formula the ones are just going to be changed with 2. So this was the basic one-dimensional case. Now we are dealing with a problem of two-dimensional, much more interesting and a little bit more complicated, but not that complicated. We are gonna simplify our problem just like this one. So just be with me. Let me just change the color again. So now we are analyzing a case of 2D collision. So what happens in 2D collision? Well, let me suppose this is the first ball in our collision, and this is the second ball, and the speed of this ball, let me just say that the speed of this ball is in this direction, and the speed of this ball is in this direction. Okay, so how can we analyze this one given that we know what happens in a one dimensional case? So a better way to solve this problem is that what if we just break the velocities in two perpendicular axes. But what will be the two axes? Well, if you think about it a little bit carefully, then you will find out that uh, if we just draw a line connecting the two centers, and we say that this is the line, the normal to both the circles, right? Because we have assumed the balls to be perfect circles. And if I just draw a line perpendicular to this line, same for this one also, then we can break these velocity components along this perpendicular axis. So let me just show you the resolution. So this is the velocity component of the first ball's velocity along this direction, and this is the component along that direction. And we can do the same thing for the second ball also, this direction and that direction. Now just for a moment, just forget about the components which are perpendicular to this line. Let me just call this line a dash. So for a moment, just forget about the velocity components along the perpendicular direction of a dash. So we are gonna have only these two components. And if we just see our previous example, the 1D examples, we had the similar scenario. The velocity components are along the AA line only. Okay, so we can apply the same method and we can conserve the velocity and we can conserve the linear momentum along this line. And after solving that, we can find the velocities along this direction also. And but what about these components? Well, it turns out that these components do not change. I know it's a little bit counterintuitive, but that's how physics works. Whenever we resolute our velocity component in two direction to perpendicular direction, then the two velocity components have no effect on each other. So that was the basic trick of solving a 2D elastic collision. Now let me just show you how we are gonna do it here, because I'm definitely not gonna derive the formula, because in the derivation you can see that there will be the thetas there to resolute the vectors, and also the the angles with respect to a global coordinate system, like that. But I'm not going to derive that. I'm going to show you the Wikipedia page where you can actually find the formula. So let me this is the Wikipedia page, by the way. uh, so if I just scroll down a bit in the two-dimensional case, okay, so you can see that these two are the basic formulas after solving the crappy equations, the big equations. But we are not going to use these two formula. Instead, we are going to use these two formula with the vector notation. Well, why we should use the vector notation here? Because in P5JS or in any programming language, you can actually find some data structures called as vectors, which will gonna store a set of values. And if we gonna use the vectors intelligently, then we can actually encode the angle information in the vectors only. You can see that here the same thing is written, but in vector format. And in vector format, if you are familiar with the vectors, you must be familiar with the concept of dot product, which is exactly used here. You can see that the inner product, dot product, the angle brackets indicate the dot product. So this is just a dot product of these two vectors. And by the way, the bold letters here actually denotes the vector. So we have a vector corresponding to the velocity of the first ball, and which is denoted as v1, and v2 denotes the velocity vector corresponding to the second one, and x1 and x2 just denotes the position vectors of the following balls. So by knowing this vector notation, we are going to code our system, and it's gonna be real fun. So that was all for the conceptual part. Now I'm going to jump into the code section. So as I told previously, I'm going to use p5.js, which is the JavaScript based framework and which really helps you in the animation portion. So you can actually do it programming language of your choice, but I recommend p5.js. Okay, so to do the p5.js coding, first of all you need to make a index.html file, and this is the boilerplate for it. You can find all the files used in my GitHub repository, and the link will be given in this description, so please make sure to check that out. And in this project I have used quite a lot of UI, but I'm not gonna explain the code for UI because I want you to come up with your own UI that will be probably more interactive than mine. So let's get started with the basic structure of the code and how the actual physics is implemented in the code. So here you can see that I have two main files here. First one is sketch.js and other one is ball.js. I don't know if you can see it very clearly in the YouTube. This file actually corresponds to the ball class, and we are going to actually declare the object of this ball class for the red ball and blue balls. Okay, so this is how you can make a class in the JavaScript, and this is just the basic syntax of function, ball, and couple of arguments, and then the description. So it is very clear to understand that m denotes the mass, x denotes the x position, y denotes the y position, and d denotes the diameter here. Okay, and here you can see that I have created a vector. Well, in p5.js you can create a vector by just writing this line, create vector. Okay, so this dot p is a vector which takes the value x coordinate and y coordinate. Okay, and then I have declared another vector which is the this dot v, which represents the velocity vector obviously, and initially I am just passing two values 0 and 0. Now here is the display function. Well, actually this display functions just shows the balls, and here I have just drawn an ellipse. Okay, in p5.js ellipse is used to draw the circles. And after that I have a update function. Well, what it does, it just updates the velocity, updates the position vector. You can see that this dot p dot add, that simply means we are adding some value to our previous position vector, and the value we are adding, you can guess from the formula, the basic physics formula, which is the new position would be equal to the previous position plus velocity multiplied with the time. And here dt actually is the smallest unit of time here, and I have defined it here in the global as the global variable. Dt is equal to 1 in my case, and you can actually vary this to see different kind of situations arises. That will be just changing the speed of the simulation. After that I have written a function which is collision. Well, this is the first important function. Why? Because it detects when a collision occurs. Well, uh, these are the round objects, the round balls. So how you can detect the collision? Well, it is very simple to do. What you need to check, we just need to check the distance between the two centers is less than or equal to the sum of their radiuses or not. So if the distance between the two centers is equal to the sum of their radiuses, then we say that okay, a collision occurs. And after that, the most important function, which is the after collision. Well, what it does, it calculates the velocities after the collision. So first we are going to calculate the velocity of ball A. How can we calculate that? Well, it is very simple. We are just implementing this formula here. Let me just show you this formula. So v1 dash represents the velocity of the first ball after collision, and v1 represents the velocity of the first ball before collision. So you can see that there are couple of terms here, a couple of numerator terms and couple of denominator terms. And if you just see my code here, I have just separated out the terms for my convenience. And the a coef is the this term. Okay, this is the a coef, And by looking my code and comparing to it and comparing the Wikipedia page, you can easily understand this. And after that, you have to do the same for ball B also. And two things I'm going to mention here is that the dot max square actually finds the value of this thing. So this is x1 is a vector and x2 is another vector, and we are interested in finding the square magnitude of their differences. So first we're gonna take the subtraction of these two vectors, and after that we are going to take the square magnitude. That's what is done in this line. And the second thing is that the dot product one. So in p5.js, if you just write dot dot after a vector, we can actually find the dot product corresponding to the vector. So where do we need the dot product? We need the dot product here, the v1 minus v2. Obviously there are many ways to code the same thing, but this coding technique suits me the best. Okay, and after you have calculated all these things, you must remember to update the velocities simultaneously, because if we just write the this line here, because I am in object A, so this represents the properties of object A and other represents the properties of another object. So suppose I am calculating all these things with respect to A, so this represents A. So what if I just write the code, this line of code here, and let it stay here? So what will happen is that it's gonna change the value of the velocities of the ball A. So when I am going to get into this calculation, it calculates the wrong value of velocity for ball B, because in this formula also we need the value of velocity of A. So remember that we need to update the two velocity vectors of the two balls simultaneously, and we can do only after both the calculations are over. So that was the most important function, the after collision function. And after that, the easy function, which is the this dot arrow. This just uh, takes the velocity and draws an arrow in proportion with the velocity. Okay, so the larger the velocity, the greater will be the length of the arrow. So that was all for the ball.js function, js file. And after that we are going to look at the sketch.js file. Well, it is basically a file where the main components are arranged. So this is very easy one actually. So there are the couple of variables, and after that we have the setup function, and in setup function we are going to set up our canvas, we are going to set up our all the sliders, the buttons, and you can definitely do this by your own research and do not need rigorous explanation. And the interesting thing here is that I have used a variable named sim. Well, sim is a short form of simulation, I have assumed that. So what it does, well, if you look into our the final web app, then you can see that we have basically two states. One state is the running state, and other state is the steady state where nothing is moving, where you can actually change the position of these things, you can alter these things, but while running we can't do that. So we have two states, first one is running, another one is steady. So to denote the states, we have used the variable sim, and when sim is 1, we assume that it is in steady state. Sorry, when the sim is false, we assume that it is in steady state, and when the sim is true, we assume that it is in simulation state or it is in running state. Okay, so here is another function, initial function. This actually takes your web app to its initial position, and this is the draw function, which is very important for the animation purposes. So you can see here we have if statement which checks if the sim is true or false. If it is true, then only we are gonna update the positions. This is important, because we can't update the position of the balls if the sim is false. and if the sim is false, then all this kind of things will happen. And we can, in the false state, that is in the steady state, we can update the positions only by the sliders. We can change the velocities only by the sliders. We can change the angles only by the sliders. No effect of the another ball will be observed here, because in the steady state there will be no collision. So that is important. And after that we are going to just display the balls, and after the display we are going to display the arrows also. And at last we are gonna check if the collision actually happened or not. And remember that the draw function actually loops over and over. So this is the function which is gonna give you the animation effect. So that was all for this video. I hope that you understood the concept of the 2D elastic collision and understood the basic concept of how you can code the physics stuff. And if you have any question, please write them in the comment. If you like the video, then please share the video with your friends. Subscribe to Normalized Nerd, and thanks for watching.